Hi everyone, in this video I will teach you how to find a cycle in a directed graph using DFS. And if you have seen all other videos of YouTube, then everybody is saying that you should be having a parent map and you should keep track of recursion stack. But I will tell you that you don't need to have these two things, and just having a visited array is more than sufficient for you to find the track of if there is a cycle or not, right? And I'm damn sure that nobody will be able to solve it without this thing, right? But I will be teaching you. First of all, I will give you the logic, then I will do a dry run, then I will do a live coding, and then again I will do a dry run. Why? Because you need to do a dry run as per your code, because if you are doing a dry run that is way more away from the code, then you will not be understanding how the code is working. So that's why a dry run after the code is really important. I will be doing all the things in this video, so just keep watching with me. And now, first of all, I will tell you what is cycle. First of all, if you are starting, let's suppose you are starting, you are at current node, that is 0, and you are starting at this point, and by moving forward and you are coming back again to that node, it means you're starting. If your starting and ending is same, it means there is a cycle. If the starting and end is not same, it means it doesn't have any cycle. I will give you an example. Let's say 0, 1, 2, 3. So you started at 0, then moved to 1, then 2, then 3, and ending at 0 again. So starting and ending is same. So there is a cycle. But let's suppose if I change the direction, right? So you started at 0, 1, 2, 3. But you can't move forward from 3. So it is ending. Starting and ending is not same. So it means it doesn't have any cycle. I hope you got the concept of cycle. Now how will we proceed further? Right, so basically our logic will consist of three things. First of all, when, let's suppose there is an example 1, 2, 3, 4 and 5. I will be doing a diagram with a complex example after writing a code, so it will be much easier for you. I'm just taking a simple example right now. So first of all, you need to see that you are standing at current node, right? When you are starting at current nodes, you need to make sure that initially you will set all as false. It indicates, false means it indicates that they are still not visited. So you are standing at 0, so first of all you will set it as true because you have visited the current node. So set it as true. Now after that you need to check its neighbor, right? So checking neighbor of current node. Now then you have to do a DFS call. DFS call to those nodes that are unvisited, means false, right? And if you are, let's suppose you are at this point and you will found out that if a node is visited, if you are at current node and if you are checking its neighbor, and if the neighbor found out to be true, it means there is a cycle in it. And there is one fourth point that is most important. I will be putting that after doing a dry run, right? So you are at 0, now set it as true. Now check its neighbor. So 0's neighbor is 1. Now you are at, you check its neighbor. Now do a DFS. When can you do a DFS? When it is false. So it is false. So do a DFS. Now you are at 1. First thing is just make it as true. Now do a DFS. Now check its neighbor. So one's neighbor is 2. Is it false or true? It is false. So do a DFS, right? So do a DFS, and so you are doing a DFS at 2. So first of all, you need to set it as true. Now check its neighbor. So three's neighbor is two's neighbor is 3. Now 3. Now you are able to do a DFS because it is true. Now check its neighbor. Three's neighbor is 4. That is false. So you can do a DFS. So first of all, you need to set it as true and then do a DFS. Now you are at 4. Now check its neighbor. Four's neighbor is 1. Now check if it is true or false. It is true, so you can't do a DFS. It means there is a cycle in it. So this way you can find out the cycle. But there is one exception, and I will tell you that is why the 4th point is important. So 0, then 1, then 2. Now it doesn't have cycle, but as per our code it will give us cycle. How? I will tell you. Now you started with 0, so first thing you need to do is set it as true. Now do a DFS. Now sorry, go check its neighbor. So zero's neighbor is 1, so it is false, right? So make it as true and do a DFS. Now 1 doesn't have any neighbor. Now you need to move back to 1. You are done with this thing, right? Now start with 1, right? 1 is already set as true, so it's time to check its neighbor. So 1 doesn't have any neighbor, so you are done with 1 also. Now start with 2. So first of all you need to set it as true. Now check its neighbor. So two's neighbor is 1. Now check if it is true or false. It is true, it means there is a cycle in it as per our code. So there is one mistake that we are doing. So when we are done with the current recursive call, then when we are returning back from it, so we need to do, when we are backtracking, it means we need to set the current thing false again. Right now, again doing the same thing. So the 4th point is really important, making it false again. So 0, 1, and then 2. Right. Initially all are false. So you started with 0, then first thing you need to do, set it as true, then do a check its neighbor. So zero's neighbor is 1. Now it is false, so you are able to do a DFS. So when you are doing a DFS, then the first thing that you are doing, you are setting current node as true, then checking its neighbor. So there is no neighbor of it. Now it's time to return back from that. But before returning back, you need to set it as false. So I will set it as false again. Now I will return back from this point. Now I am done with all the neighbors of 0. So now it's time to set it as false. Right now I'm done with 0. Now I start my DFS with 1. So 1 is false. I need to make it as true. Now I need to check its neighbor. So there is no neighbor of 1. It means I'm done with 1. So it means I need to set it as false again. Now I'm done with 1. Now I will start my DFS with 2. So first thing I will do, make it as true. Now I will check its neighbor. Its neighbor is false, so I will be able to do a DFS. I will be doing a DFS with 1. So first thing that I will do is making it true. Now I need to check its neighbor. So 1 doesn't have any neighbor. It's time to return back from 1. Now, so before returning back, I need to set it as false. Now I'm returning back at 1. I'm at 2. I'm done with its neighbor. I'm done with its neighbor. Now it needs to return. It needs to set it as false. So everything is giving me false. It means it doesn't have cycle. I hope you got the point. Now I will be doing a live coding, and then after the live coding, what I will do, I will be taking an extreme example, and I will be solving it as per the code. So you will be able to understand the code also. Now it's time to do a live coding. Yeah, one more thing I want to tell you is that there can be a example that it have a component. So this is one component, and then there is one more component. uh, 4, 5, 6, 7. So I will be doing a recursive call with 1. So I will be able to go through all this, but I will not be able to go through all this thing remaining, the other component 1 component. It can have multiple component. So to do a DFS in all the components, so that's why I will be using a for loop. So if I am starting with one, then I will be able to done with that. But for that only I will be using a for loop. So that I will be doing a recursive call at every node, so that I will be covering up all the components. Now I will be doing a live coding. So first of all, uh, I need to I need to make a vector of bool type that is visited, right? And what should be the length of it? It should be the length of the adjacency. uh, and initially all I am setting it false. Adjacency means, let's suppose 0, yeah, 0, 1, 2, 3. So adjacency means like it is saying that 0, how many neighbors 0 has. So 1, then 1, let's suppose there is 4. How many neighbors 1 has? Uh, 2 and 4. Then how many neighbor 2 has? Only 3. 3 has only, there is no neighbor of 3, right? So it is empty. So this length will be equal to adj dot size, right? Now I will run a for loop because I wanted to check its all the components. Int I equal to 0, I less than adj dot size. Don't worry, I will be doing a try run with this code also, with the extreme example. If the visited of I is false, then only I will be doing a recursive call, and DFS I then adj then visited. So if the type of that recursive call should be true or false. So if it comes out to be, yeah, if this comes out to be true, it means it has a cycle. So if it comes out to be true, so I will say return true because I have a cycle. But if doing all the DFS call and all the for loop, if there is no cycle, it means I need to return false. Now I will be writing a DFS function. The type of that should be bool because it will be returning me true or false. So bool DFS, uh, this is int current node, current, then this thing adj. Now vector of bool, I will be pass it as uh, passing a by reference because I will be doing a backtrack, so that's why I can pass it by reference. I will be explaining this code, don't worry, with the example also. Now first thing that I told you, I need to set the current as true, then checking its neighbor. So for auto and checking of neighbor of what? Neighbor of current, right? And now I will be doing a DFS in the current and the neighbor. The neighbor is if the neighbor is false, I will be doing a recursive call from that. If neighbor is false, the same thing I will do. I will set neighbor as current, and then I will be doing a recursive call on that. And if it comes out to be true, I will say there is a cycle, so I will return true, right? And if the visited is true, it means there is a cycle in it. So I will say return true. And in the end, if nothing is working out, it means there is no cycle. So false. But before that, I told you one more important thing. I need to set it the current as false again, right? Now I will run this code. I will be explaining this code. Don't worry with the extreme example. It is taking time. Okay, it is submitted successfully. Now I will be doing a try run so that your understanding will become good. Yeah. Now I will be taking an extreme example. Let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so this, this. Yeah. Now I will be doing a dry run. So I started at 0. I'm at this point. I started with 0. Initially all are false, right? Yeah. Now initially all are false. I starting with zeros. First thing that I now see 0 is false. Initially all are false. 0 is false. So I will do a recursive call, making 0 as my current node. So I'm at this point, right? Now first thing I need to do, make it true. So I will make it true. Right now, I will check its neighbor. So the first neighbor of 0 is 1. Check if it is true or false. So it is false, right? 1 is false. So I will do a recursive call making neighbor as my current. So my current thing is 1, right? So first thing I need to do is making it true. True. Now it's time to check one's neighbor. So one's neighbor is 2 and 3. So I will start with 2. Right now check if 2, sorry, it is false. So 2 is true or false. So 2 is false. So I will do a recursive call at 2. Now I am at 2. Now I am at this point. So make it as true. Now check its neighbor. 2 doesn't have any neighbor. So this will not work for 2. Now I am at this point. It means the current node I need to set it as false. So again false. Now I need to return false. So I will return false to 1. Now I came back at 1 again. I was done with this and I'm checking its neighbor. So I'm done with its first neighbor. Now it's time to check its second neighbor. So the second neighbor is 3. Now check if it is true or false. So the second neighbor is false. So I will be able to do a recursive call at DFS and making 3 as my current node. So I am at this point 3. Right now check 3. First thing I need to do set 3 is current, so set current as true. So true. Now check 3's neighbor. So 3 has 1, 2, 3 neighbor. Now I will start with 4. So check if 4 I'm at this point. Now check 4 is true or not. So 4 is false. right? So I will be able to do a recursive call making 4 as my current node. So I'm at 4 right now. First thing I need to mark 4 as true. So true 4. Now I need to check 4's neighbor. So 4's neighbor are only 5, right? I need to check if it is true or false. So it is false. So I will be able to do a recursive call making 4 as my current. Now I'm at 5 as my current. So I'm at 5. Now first thing I need to do is making is true. Now check its neighbor. So 5 doesn't have any neighbor, right? 5 doesn't have any neighbor, so this will not work. Now I came at this point, right? I need to mark the current again as false, so I will mark it false. Now it's time to return false, so I will return uh, false to 4, right? So I will return false here. Also I returned false here also. Now I'm at 4. Now I'm at 4. I'm done with this point. Now I was checking a neighbor. So 4 only has one neighbor. So I'm done with all the neighbors of 4. So I'm done with this. Now it's time to set it as false. False again. Now it's time to return false from 4. I will return false at this point. Right now I came back to 3 again. I was done with this in 3. I was checking its neighbors. 3 has 3 neighbors. 4, 5 and 7. I'm done with 4. Now it's time to uh, go to 5. Now I'm at this point. Now check 5 is true or false. So 5 is false. I will be able to do a recursive call. So now I'm at 5. Now it's time to make it true. So I will set it true. Now check its neighbor. So 5 doesn't have any neighbor, so this will not work. I'm at this point. Now again set it as false. Now it's time to return false from 5. So I will return false from 5. Now I'm done with 5. Now I came back at 3 again. Right? I came back at 3 again. I was done with this. I was checking its neighbor. So I'm done with it has 3. So I'm done with this and this. Now its third neighbor is remaining. So now check 7 is false or true. So 7 is false, right? 7 is false. So I will be able to do a recursive call at 7. Right? Now check I'm at 7. First thing I need to do is make it as true. So I will make it as true. Now I need to check its neighbors. So 7's neighbors are 8 and 9. I will start at 8. 8 is false, right? 8 is false. So I will be able to do a recursive call at 8. Now check, and now I'm at 8. First thing I need to do is make it as true. Right now check its neighbor. So 8 doesn't have any neighbor, so this will not work. Now I will need to set it as false again. So false again. Now it's time to return back from 8 and return what? False. So I will return false. Now I am again at 7, right? I am done with this and I was checking its neighbor. So 7 has 3 neighbor, this and this. I was done with this. I will check its second neighbor. I can check 0 or 7. It doesn't matter, but for your understanding I will be doing with this also. So I will be checking 9 before 0. I can do 0 or 9, it's my choice. So I will be checking with 0. Now 9, I'm at 9. No, I'm checking its neighbor, that is 9. 9 is false, so I will be able to do a recursive call. I'm at 9. First thing I will do, I will set it as true. So true, true. Now check its neighbor. So 9 have a neighbor, that is 9. 8. 9 has neighbor, that is 8. So I will do a recursive call if it is true. If it is false, so it is false. So I will be able to do a recursive call at 8. So first thing I will do, I'm at 8. I will set it as true, right? Now check its neighbor. So 8 doesn't have neighbor, so this will not work. Now I need to set it as false again. So false. Now it's time to return false from 8. So I'm returning false from 8. Now I'm came back at 9 again. I'm done with this, and will I be able, like I have checked all the neighbors of 9 or not? Yes. the neighbor of 9 is only 8 and I'm done with it, so it is done. Now it's time to set it 9 as false again. So false. Right, now it's time to return back from 9. So I came back at 9, and what I will return false. Now it's time to uh, go. I'm at 7. I'm done with this, and I'm just checking its neighbor. So I'm done with its two neighbor. Now it's time to do with the third neighbor, that is 0. Now check if 0 is true or false. So 0 is true, so this will work, and I will return uh, true. So I am at this point. Now I will return true to 7, right? So once again I came back again. So this will return true. This 0 will return true. So I am at 7. I'm done with this, and I'm done with this neighbor. Uh, like I'm at its neighbor, and this neighbor is returning true. So I need to return back from 7 to 3. Now I am at 3, and what I will return true, right? I'm at 3, so I will return true at 3. I'm at 3. I'm done with this, and I am done with I'm checking its neighbor, and the seventh neighbor is returning 3, so I will return 3 to I will return true. I will return back true, so I will return back true to 1. So I am at 1. I'm done with this, and this thing is returning me true, so I will return back to its parents, that is uh, this 0. So this 0 will return this thing, that is true to 0. So I'm at 0, right? I'm done with this, and this thing is returning me true, so I will return back to the thing where it was called for the first time. So I will come back at this point, and this thing is returning me true, so I will set it as true. So the answer is true. This graph has cycle, and that cycle is this. I hope you got it. If you do it with yourself, then you will get a lot concept clarity in your mind. So clarity in your mind. So I hope you will do it by yourself. So that's all for the video.